Let's look at a TMUA past paper question, because I think it really nicely demonstrates what makes the TMUA stand out a little bit on the maths front in terms of how the questions behave and how they're structured. Here we're being asked which statement A, B, C, D can this equation here be used to produce a counterexample of? Right. So this idea of proof, examples, counterexamples, if statements, if and only if statements, as well as all kind of like logical implications. So A prime implies B and things like this. Certainly worth reading up on, familiarizing yourself with, because you will need it for the TMUA. So I'll give you a second to read this question, give it a go, and we'll work through it together. All right. So to be a counterexample, what does that actually mean? It means that one of these statements is wrong, and our equation is proof that the statement is wrong. So our equation by itself contradicts the claim made in A, B, C, or D. So it's not enough for the A, B, C, D to be wrong. It has to be wrong, and our equation demonstrates why. And it's not enough, certainly we don't care if the statement is right, and our equation is an example of it being right. That's also of no use to us whatsoever. We need a wrong statement, and this equation is why. So let's look through. Question A. So A, B, C are positive integers which satisfy. Fantastic. And the three numbers have no common divisor. Brilliant. So does this apply here? Well, no, it doesn't. I mean, we have three even numbers, don't we? So actually, I don't even care what the rest of the statement is, because our equation does not pertain to this at all. Right? Our equation is about numbers that do have a common divisor. So I really don't care what condition we're about to impose on them, because it's a condition unrelated to the equation. Our equation can't possibly be a counterexample of that. So it's not going to be A. Let's look at B. A to the 4 plus B squared equals C squared has no solutions. Okay. Now, I think initially this looks completely, again, A to the 4, that's clearly not our question here. However, we can actually express one of these as A to the power of 4, can't we? So we shouldn't immediately dismiss here. We should maybe push a little bit. Does this equation actually look like A to the power of 4? Because it does, doesn't it? 16 is a square number. 16 is 4 to the power of 4. So I suppose it's, this equation exactly right. 16 squared, 4 to the power of 4. These are kind of the same thing. So I guess we're allowed this little bit of lenience in our definition here. Now, B is claiming that there are no solutions for this. Our equation demonstrates a solution for this. So actually, we've succeeded here. This is our counterexample. B is our answer. Now, in an exam context, what I would do here is I would read through, again, B and the equation a couple of times. Make sure that I'm certain, yep, this is a counterexample, and then I would move on. I would not read C and D at all. They're not worth my time. They're not worth the mental strain that it takes to figure out what is a counterexample, what isn't. Just ignore them. Move on. If you happen to finish the 75-minute test of 20 questions with enough time to spare, then by all means come back and verify this. It's not worth your time now. We'll do it for fun anyway. So let's look at C. The equation A to the 4 plus B to the 4 equals C to the 4. Again, requiring integer ABC. Well, hey, in this case, that's certainly not a problem, isn't it? Because 12 squared, well, that can't be expressed as anything to the power of 4. The square root of 12 is irrational. It's not an integer. So it's certainly not C. Now let's look at D. One is the arithmetic mean of the other two. So meaning like plus wise, it's in the middle. So 16 is in the middle of 12 and 20. 12 plus 20 divided by 2 is 16. So this is a statement that is actually wrong, but here's a demonstration of it happening to be right for one specific case. That's not what a counterexample is. A counterexample is here's the statement being wrong. So again, we wouldn't care about D either. I think that of all the admissions tests, the TMUA has the most distinctive style here in terms of asking a very specific type of questions. Right? I think economics does tend to care more about this. think really critically about the implication of this word. What does this mean? They like that aspect of the mathematics here, rather than mathematical techniques, which are more common, certainly, in the other exams, because while the subject is maths based more for the other exams, pure math based, so they care more about your ability to do maths as well as use maths to investigate logic.